Hi guys, so this is Debarshi, and it's been a while since I've done one of these. So today I decided to revamp my C++ programming tutorials on YouTube. I'm not going to delete my old videos, as I think that they could be a great point of reference, but I feel that that's exactly what they are. These old videos that I created on C++ programming, they were less focused on the actual practice of programming and more focused on teaching programming through facts, through the idea, uh, through basically memorization. I think that it encourages the memorization of facts and different commands and programming and whatnot in C++. And I feel that this is not the proper way to learn programming. I think that C++ programming needs to be taught through practice. And what I'm going to do is I'm going to take the first video, or maybe the first 2 or 3 videos from the first playlist, and incorporate them into my second playlist. And those 1, 2, or 3 videos, however many, I'll decide later, um, will serve as the basis, like fundamental concepts that you need to know for every single program. And it's important to watch those videos. But after that, these videos are solely going to be concentrated on teaching the concepts of programming through actual practice. You guys are going to watch me create full-length programs and watch me execute them. Um, and and as you watch me do this, you'll see the programming process, and you'll understand what it is in real life, what it is being a college student as a programmer, and what it is being in industry as a programmer. I really want to do this for you guys because I feel that programming is not just a bunch of facts. It's actually a lot of logic, it's creativity, it's thinking, and I need to get you guys to have this experience with me. So this is something new I want to try. So to get started, I think you'll notice that unlike a lot of my other videos, I have a Mac OS X development environment. If you have a OS X development environment, I recommend you use Eclipse over here. I recommend this for Windows too, but what you're going to need to do is set up Eclipse with a debugger if you intend on using a debugger. I don't use debuggers for most of my projects. That's not necessarily a good approach, but for simple projects, uh, the debugger sort of just works under the hood. You don't necessarily have to use it to debug anything for simple projects, but for higher level projects, those projects could require a debugger could be extremely helpful. I remember that when I initially started out on this operating system using this IDE, because macOS 10.7 stopped shipping with GDB, I had trouble configuring Eclipse with GDB. And as such, I actually didn't use a debugger to debug my programs. Instead, what I did was I used a bunch of print statements, and I debugged on my own. I hand wrote the code, and I did all of that hard mess. And if you don't understand what I mean, you don't have to right now. I guess I'll show you what I mean later in a different video or whatnot. But to sum it up, if you have a debugger, it can be really useful for long length programs. The debugger always works under the hood. That is something you need a debugger, there's no doubt about that. But you don't necessarily have to use that debugger to like debug a program unless it's a very big program. That's where a debugger really helps. You can use print statements and whatnot to and breakpoints to actually debug a program without using a lot of other fancy debugging features. But it helps to use those fancy debugging features nowadays. It makes things extremely quick. So without further ado, let's get started. I'm on Eclipse. You can get this at eclipse.org. So we are going to go down to File, and we're going to click New, and we're going to go to C++ Project. You're going to have this menu right here, and you're going to create a project name. We're going to call this Average of Values. Actually, before I get started with this, I think I'm moving on ahead a little too quickly. This is my first video in this series, so please forgive me if I stumble a little bit. But the book that I'm gonna be solving problems, programming problems from a book, and the book that I'm going to be using as a point of reference is C++ from control structures through objects. And it is available on Amazon. It is available online as a PDF, as an EPUB, as a hardback copy. You can get it. I highly recommend getting this book or another C++ programming book. But I also will strongly suggest against using this programming book as a read to front to back novel or something. That's not something that I like with programming. There are some people who will get away with that in the beginning, teaching basic programming or simple programming. That's, you might get away doing that, but what you really want to do is you want to stop, you want to discourage memorizing this information. You really want to practice it and learn it through experience and not through osmosis. So without further ado, let me show you the problem, the first problem. And we're just going to be doing 3 problems from each chapter or so. So this is the average of values problem. To get the average of a series of values, you add the values up and then divide the sum by the number of values. Write a program that stores the following values in 5 different variables: 28, 32, 37, 24, and 33. The program should first calculate the sum of these 5 variables and then store the result in a separate variable named sum. Then the program should divide the sum variable by 5 to get the average. Display that average on the screen. So remember that a variable is an allocated place in memory. It has a magnitude, a certain amount of space, and whatnot. And remember that variables are defined by data types. Those could be integers, floating point variables, double precision variables, or booleans. Examples of integers are 1, 2, 3, 4, 5, etc. without decimal points. Floating points and doubles have decimal points. Floating point has less number of significant digits. Double precision has a more number of significant digits, so it's more precise. That's hence why it's called double precision. And booleans are true and false values. Under the hood, everything in computer science is like booleans, ones and zeros. I mean, computers run through binary. It's an important fact to note. And a true is 1 and false is 0. Some languages don't actually spit out true or false. They spit out ones and zeros, like the computer reads those variables in under the hood. So, to get the average of a series of values, you add the values up and then divide the sum by the number of values. Write a program that stores the following values. Okay, so let's stop there. First thing you're going to want to do is create this project, and I recommend selecting, you're going to have several different options. You can use an empty project and work with the program structure video that I showed you earlier to create a simple program, but I recommend using the Hello World C++ project as a stock program, as a skeleton for a program that's already built. Don't select cross GCC. You're going to see this in Windows 2. Don't select it. It's not going to work. Select the other option like Mac OS 10 GCC. On Windows, you're going to have to set it up with MinGW or another compiler or something like that. I highly recommend MinGW, which contains GCC. But yeah, make sure you don't select cross GCC. You can skip this. You can totally skip this and just click finish. Okay, so, and it's going to show you some red errors at first. Give it a second. Click on it. Ignore the errors and you can just start working on the code. As you can see, the errors just disappeared. So before we try to solve this average of values program, let's just see if this program works. Run it. Wow, binary not found. That's interesting. Oh yeah, that's because the first time that you run a program, you actually have to go into the build menu. So you have to go into project and you have to build the project, like you have to actually click that. I know it's sad and it's really boring, but I mean it's what you have to do. And then you click run. And finally it prints out hello world, as you can see there. So we know our program works, we know what it does. It prints out hello world, as you can see right there. So all you got to do now is, since we're not creating a hello world program, delete that. Everything else you will need. You will need this preprocessor directive, and if you don't know what that is, look at my first video. Using namespace standard, you don't really need this, but if you don't use it, you're going to have to put std::cout or std::c input. In other words, just use it, using namespace std. And int main, you're going to need that. That is the main function, and it is necessary in every single program you're going to build. Return 0, that's going to ensure that your program returns correctly. So let's start. So if we look at the instructions for this program, to get the average of a series of values, you add the values up and then divide the sum by the number of values. Write a program that stores the following values in 5 different variables. So we have 5 different variables. They're all integers: 28, 32, 37, 24, and 33. You see there's no decimal points or anything. So you want to create int a. Let me just zoom in so you guys can see this. And then we're going to create int b, c, d, and e. And we're just going to set it like that. Now, you can also put these on different lines, but if you were to put them on different lines, you'd actually have to like do these separately, and it would just take up so much space with semicolons that I just prefer to use one line. And I mean, it doesn't really matter. It'll do the same thing. Excuse my sniffling, by the way. It's that time of year again. That season. Okay, so we have 5 variables, but the problem right now is we haven't actually set the values for these variables. How do we do that? And this is going to be like a simple math statement. Sorry, let me zoom in again. So remember that a variable is an allocated place in memory. That is true. However, the good thing about variables in any programming language is that you can set them like any integer or any mathematical expression, algebraic expression. So all you got to do over here, if I can zoom into the code, set these values like a equals, what's our first value? 28. And then we can set b equal to 32. And then we can set c equal to 37. We can set d equal to 24. Then we can set e equal to 33. Okay. So we've set the values of the integers. Now what do? We are going to create a sum. The program should first calculate the sum of these 5 variables and store the result in a separate variable named sum. So there's going to be a sum, and we can use an integer. I mean, all of these 5 values are integers, so it's going to add up to an integer. So we're going to call it int sum equals a plus b plus c plus d plus e. Now, here comes the tricky part. Then the program should divide the sum variable by 5 to get the average, display the average on the screen. So you have an option. You have several options here. What I like to do is set up a separate variable for this division. I prefer that. You can also print out to the screen using Cout, and you could do something like sum divided by 5, and you can cast that to a double. So let's use this method first and see what happens. So let's just run this program first and see what happens, and then we'll talk about everything else. So it's building. We're given an answer, 30.8. Okay. So this is interesting. And this is one way to do it. You can just put a print statement and do the calculations inside that Cout print statement. That's one option. Another option is, so we're gonna label this. We're gonna call it printing with Cout. And this end line over here, by the way, is used to skip to a new line. So we're going to demonstrate how this and what I'm about to show you does exactly the same thing. So what I'm about to show you is we're going to create a new double variable called average. And we're going to put that same calculation in there, double sum over 5. Copy, edit, paste. Now, what I've done over here is a cast, this double cast right here, because sum is an integer, and 5 is also an integer. I wouldn't necessarily have to use this cast if I did sum divided by 5.0, because that would automatically cast it to a double. But because I'm not using that, I have to cast it using the double name tag, basically. And what that does is it treats sum over 5 as a double calculation, and then stores that variable in the average variable. This is the same thing going on under the hood for this Cout statement right here. When you're basically doing the same thing with this cast, double sum over 5, only it's not using an intermediate variable. So now we're going to do Cout, and we're going to say in quotes, we're going to say printing average using intermediate variable. And then we're just going to put average. And we're going to put end line. That is something I prefer to do because I prefer to skip a line between each console output statement. By the way, Cout stands for console output. And then we're just going to, now in the beginning you actually had to like click project and build project and then run it through this menu, but you don't have to do that for the subsequent iterations of running it. You can just click this green build button, which I will zoom in right now. Click it, click OK. As you can see, they get the same value, the same calculation, same value. So printing with Cout, we get a 30.8. Printing average using the intermediate variable, we get 30.8. But what happens if we didn't use this cast at all? So what we're going to do right now is we're going to print with Cout using a cast. So we're going to change this to print with cast, and then print average using no cast. And we're going to see what happens. So we're going to omit this cast right here for the average variable. Actually, we don't even have to use an average variable anymore. That was just to show that you could do it through a variable. You can omit this variable, this average variable right here for at the Cout statement. What we're going to do is we're going to use this same type of notation here inside the Cout statement, and we are going to omit that cast, and we're just going to say sum over 5 and see what happens. So one statement should say printing with cast, and it's going to print the result with cast, and then printing the average using no cast, and that's going to print the average with no cast. And if we run this program, average of values. Okay, so what happened over here? Printing with cast got us a value of 30.8 like last time, but printing average with no cast got us 30. Why is this? Okay, so basically what happens is when you're doing integer division, when you divide this sum by 5, they're both integers. So when you divide an integer by an integer, you get an integer unless you cast it to a double. And what's going to happen is instead of 30.8, it's not going to round up to 31. All it's going to do is truncate or take off that 0.8. It's going to chop it off and it becomes 30. So this is a significant error in so many different programs I can name. In 1997, I want to say, or 95, I don't remember, but there was this rocket, I think it was like Orion 5 or something like that, and NASA made some miscalculations using exactly this. Like, this is exactly what happened, I think, or something similar. And some easy mistake like this can actually cost millions of dollars. It can cost a company millions of dollars. So remember, when you're doing average value calculations and whatnot, always, please, always use a cast. I cannot stress that enough. Try to use a double cast right here, because most of the time when you do averages, you want to be precise. So you can use double, sum over 5. And yeah, you can do casts with literally any variables as long as they're compatible data types. So int and double, you can cast an int to a double. But you cannot cast, in Java, you can't cast a double to an int. In C++, unfortunately, you can. It might throw you off with a warning, but that's it. You can still run your program. It's just going to truncate your result from the double. So, alright, this is our first program, and I will see you next time with the next program. Thank you very much. This is Debarshi Kundu signing off.